Hi friends, welcome to KPB Coding Hub. In this Python interview questions sequence of videos, the next question what we are going to discuss is 44th question. Here I'm talking about bitwise operators. There are multiple layers are there in bitwise operators. We are going to talk about explain about okay bitwise and bitwise or and bitwise exclusive or. In short form it is called as xr exclusive or. So let us talk about these operators in detail. The first point, it is applicable it is applicable only for it is applicable only for binary numbers. Sir, that means we are not required to convert into binary, because whatever data you are supplying in the program or in input output statements, the data internally is represented in the form of binary only, that we know. But coming to this see, and is going to return 1. So if both bits are 1, otherwise it is going to return 0. If you take r, this is called as bitwise, and symbolically we are going to use this symbol. And this one is nothing but what? Bitwise or. Symbolically we are using this particular symbol. So you know the truth table, right? But in the case of logical operators, we applied true or false or something like that. But here we have to take 0 or 1, because it internally works based on which number? Binary numbers. Now, these bitwise operators are going to return 1 if both bits are 1, otherwise it is going to return 0. Means what is the truth table of these? If the first number is 1, second bit is 1, then the result is 1. If the first bit is 1, second bit is 0, or first bit is 0, second bit is 1, or first bit is 0, second bit is 0, in all these three cases, what is the result that we are going to get? 0. So just keep this in your mind. Then this is nothing but which truth table? It is and truth table, bitwise and how it is going to work. Sir, coming to the bitwise or. So how this or operator is going to work? It is nothing but a pipe symbol. If any one bit is 1, that means either both bits can be 1, or first bit is 1, second bit is 0, or first bit is 0, second bit is 1. In these three cases, what is the result that we are going to get? 1. And in the remaining case, what output we are going to get? 0. Like that we have. Now it will return 1. So if any one bit is 1, okay, otherwise it is going to return 0. Like that we have. If any one bit is 1, it is going to return 1. Otherwise it is going to return 0. Next, we have to take bitwise exclusive or. What is a symbol we are using for this is nothing but a cap symbol. So this operator is having a special significance, sir, not only in Python, in every language. So how this cap operator is going to work? See, if both bits are in same state, means what? If the first bit is 1, second bit is also 1. If the first bit is 0, second bit is also 0. That means if both bits are in same state, then the result what we are going to get is nothing but 0. Okay, sir, if the bits are in different state, that means what? If the first bit is 1, second bit is 0. If the first bit is 0, second bit is 1. In such cases, what is the result that we are going to get? 1, sir. That means if the bits are in different direction, we are going to get 1. If the bits are in same state, we are going to get 0. Like that we have. So let us write down here bitwise exclusive or means it will return 1, sir, if both bits, okay, if both bits are in different state, else it is going to return 0. Like that we have. This is nothing but how bitwise operators are going to work. Theoretically I explain, okay, but we have to take one example and we need to see how it is going to work. Okay, I hope it is very clear for you people, friends. Okay, let us go for an example program where you can get much clarity. See, I'm reading dynamically. So a value from the user, enter a value. I want to read the value of a. B is equal to int of input. I am taking enter B value. Like that, I am reading the value of A and the value of B. After this, I am trying to print A and B. And I want to print A or B. And I want to print A cap B. Like that, I am taking three special symbols. Now we have to test how it is going to work. Let us consider the inputs which I am giving for this example is, so consider the inputs, A value is equal to, I am taking 5. Okay. B value is equal to, I am taking 9. So how it is working internally, if you want to understand, we have to convert this into binary. Then only we can evaluate easily. If you take the number, decimal number called 5, what is its binary equivalent? I am taking 8421 code. So 8421. That means by adding 4 plus 1, we are getting the result as a 5. Coming to the number 9, so 8421. By adding 8 plus 1, we are getting the value 9. Now, what is the first operation that we have to perform? A and B. Sir, what is the value of A? 0, 1, 0, 1. What is the value of B? 1, 0, 0, 1. Perform AND operation between these. 1 and 1 results 1. 0 and 0 results 0. 1 and 0 results 0. 0 and 1 results 0. Because these operators are AND operator. If both bits are 1, then only result is 1. Otherwise, result is 0. That's why, sir, what is the expected output for this? What is the binary decimal conversion for this? It is nothing but 1. Sir, we will check whether it is correct or not later. Now, what is the second one that we are doing? A or B. So, how it is going to work? What is the value of A? 0, 1, 0, 1 is there. What is the value of B? 1, 0, 0, 1 is there. Now we have to perform which operation between this? OR operation. 1 or 1, 1. 0 or 0, 0. 1 or 0, 1. 0 or 1, 1. Now what is its decimal equivalent? 8 plus 4, 12 plus 1, 13. 13 is the expected output. Later we will run the code and we will check. What is the last operation? We need to take a special care on this. What is that operation? So A cap B. So 0, 1, 0, 1, and we have to take 1, 0, 0, 1. So we have to perform which operation? Cap. We know how it is going to work. 1 cap 1 is going to return 0. 0 cap 0, it will return 0. 1 cap 0, it will return 1. 0 cap 1, it will return 1. What is its decimal equivalent? It is nothing but 12. Like this we have. Okay, so if you are giving input as a 5 and 9, these are the expected values what we are going to get. Let us run the program. Py space test.py. Enter A value, I am giving 5. Enter B value, I am giving 9. You can see the output which we expected and the output which we got. Both are matched. 1, 13 and then 12. This is the way how bitwise operators are going to work. If you want, just you can take the screenshot of this particular screen as well as the truth table which I explained previously. You can take screenshot of these two and you can practice. Okay, by taking some other integers, you try. Right? Thank you, friends.